Dear students, welcome back to the concept surface mapping. Here I am MK, and today I am going to discuss power of a lens of class 10th physics chapter reflection. I will discuss power of a lens as a whole. I mean, I will try to finish it in a single video. Okay. BSc class 10th. Power of lens. Power of lens. See students, we have two different types of spherical lens. One is concave lens and the other one is convex lens. While we are talking about concave lens, let's see, it is a concave lens, right? And it is the vertical axis of symmetry. This is the vertical axis of symmetry. Now, the case is what? What is power? In case of a concave lens, in case of a convex lens. Concave lens and for convex lens, power of lens is different. Power is different. For a concave lens, suppose say light of beam. This is principal axis which is passed through optical center P, and this is a ray of light and this is another ray of light. In case of a concave lens, there will be diverging effect. Okay, from this point, this ray will be diverges like this. If I produce this diverging ray, this ray will be intersect at point O, and it is focus of this lens. We have already discussed this, and I will going to draw another diagram of convex lens. It is a convex lens, and this is the axis of symmetry, vertical axis of symmetry, and it is O, principal axis. This is the ray of light. These two ray will be refracted into a point. These two ray will be refracted into a point behind the lens, and that point is focal length, focus of this convex lens. This is convex lens. Convex lens. Now, what I want to say? I want to say, in case of concave, there will be a diverging effect. It means concave lens diverges parallel beam of light. And similarly, in case of convex lens, parallel beam of light will be converges into a point behind the lens. Okay, it means concave lens has a converging effect, and convex lens has a converging effect, and concave lens has a diverging effect. It means now I am coming to the main point, power of lens. Power of lens is, from these two incident I can say that simply capacity to diverging for a concave lens and capacity to converging for a convex lens is called power of that lens. Correct? Clear? Simply it is the capacity. Power of a lens is capacity to, for a concave lens, diverging parallel beam of light, and for a convex lens, converging parallel beam of light. Okay, this is all about uh, power of a lens. Okay, now another point, power of lens is the reciprocal of focal length, where f is focal length. Power of lens is reciprocal of focal length. It means if focal length is increases, power of that particular lens will be decreases, right? We can say P is equal to 1 by f as different way, that is if focal length is increases, power of that lens will be decreases. मतलब power of lens is inversely proportional to the focus. If inversely proportional to the focal length of that lens. Focal length is increases, power of that lens will be decreases. Another important point I will told you, and keep in mind, whenever you are going to calculate power of a lens, you must convert focal length into the meter. Whether it is given in millimeter, centimeter, kilometer, no matter, you must convert that unit into meter. Power of a lens should be calculated as focal length converted into meter. You must convert the focal length into meter. And power of concave lens will be negative. Similarly, power of convex lens will be positive. Why it is? It is because power of concave lens is equal to, I can say P is equal to 1 by F. Focal length of concave lens is negative. It means 1 by minus F, and focal length of concave lens is positive. It is 1 by plus F. That is why power of concave lens is negative and power of convex lens is positive. Right, clear that? And now I am going to discuss about the measuring unit of power of a lens. How we will measure the power of a lens. SI unit of power. SI unit of power is, students, simply diopter, and it is denoted by capital letter D. And power of concave lens is always negative, and power of concave lens is always negative, and power of convex lens is always positive. It means power of real image will be positive and power of virtual image will be negative. Keep in mind, students, keep this important point in your mind, fit this in your mind. Okay, now what we mean about one diopter? It means, what is the meaning of one diopter of power of a lens? See, when, suppose say, you have given a lens of focal length 1 meter. You have given a lens of focal length 1 meter. It means focal length is 1 meter. 1 by n is equal to 1 meter inverse is equal to 1 diopter. We can say power of a lens is 1 diopter when focal length of that particular lens is 1 meter. That particular lens must have the focal length 1 meter. Whether it is concave or convex, no matter, that lens must have 1 meter focal length, and thus power of that lens will be 1 diopter. Clear? Clear, students? Clear. Now students, I am going to discuss another important topic, combination of power of two different lengths. I have already discussed. I will conclude the power of a lens in a single video. Okay, combination of two lenses. Suppose you have given two different lenses. One is concave and the other one is convex. Then what will happen? Combination of lenses. Suppose students, you have given a concave lens of power P1 and a convex lens of power P2. Let us try to understand this topic with the help of a diagram. Okay, suppose this is the concave lens, right? And these two lens, concave and convex, are combined together to form another lens. Okay, I will put the convex lens here and complete the combination. The power of this lens is P1 and power of this lens is P2. What will be the total power of the lens? Or what will be the total power of the combination? Total power of the combination is given by addition of these two lenses. Simply I will going to add the power of that lens. Okay, the total power of lens P is equal to given by P1 plus P2. This is the expression for the total equivalent power of this combination. Suppose students, you are given two different lens having two different power and asked to obtain the power of the combination. Then you just do one thing, add the power of that two particular lenses. But there will be another important factor. Let's try to understand with the help of an example. Suppose power of lens P1 is minus 1.5 diopter and power of lens P2 is plus 2.5 diopter. Now combining P1 and P2, I will have another lens. I can form another lens. Then what will be the power of that particular lens? Simply I will substitute here the values. P1 is equal to minus 1.5 diopter plus P2 is equal to 2.5 diopter. Minus 1.5 diopter plus 2.5 diopter. Plus 2.5 minus 1.5 is equal to plus 1 diopter. It means while combining these two lenses, there will be another lens of power plus 1 diopter. And the combination of these lenses will form a lens of power plus 1 diopter. And power of that lens will be plus 1 diopter. Students, you can calculate the power of combination of two different lenses or more than two different more than 2 or 3 different lenses like this. Okay, and students, you have to do at home and different types of numericals from different books. And I hope this video will help you to understand power of a lens and power of combination of two different lenses or three different lenses like this. And today I am going to rest my class here, and don't forget to subscribe my channels, and do not forget to write your views to me and what you want, what you have prepared, and how can help you. Write me in inbox. Okay, have a good day.